we have any questions for Dr. Schaffer? Unfortunately, I can't see if we do.
So the question is sort of what do we mean by deep? How deep can you image into tissue? So with two-photon excited fluorescence microscopy, I think the sort of current limits are around 1 millimeter, and that's actually approaching some theoretical limits. Some of these other nonlinear optical techniques, some of them will suffer from the same theoretical limits, and so I think this is always going to be a method that's sort of imaging things on the hundreds of microns to 1 or few millimeter spatial scales. But for many applications, that's a very relevant distance. So this clearly isn't going to be a way to look at your heart from outside your body, but it could be a great way to look at cells and assess whether or not they look cancerous if they're located in skin or easily accessible mucosal cavities. And it's certainly an excellent tool for biomedical, in vivo biomedical research where for example, the thickness of the cortex of a mouse is exactly 1 millimeter. So we're imaging the whole thing. Yes?
Can you compare the power requirements for this classical type imaging versus this new optical techniques that you were presenting?
So the question is, has to do with the optical power that's required for these various imaging methods, and I guess how close we are to damage thresholds with some of these. So it depends on the method. Actually, for the excited state absorption, for example, the optical power requirements are quite low because you're looking at sequential 1-photon transitions rather than direct 2-photon transitions. So optical powers of sort of the milliwatt at the focus level are more than adequate for imaging. For some of the other things, the stimulated Raman scattering, which are harder nonlinear optical effects, it's several milliwatts of power. I think I even saw some of those images were taken with up to 10 milliwatts, but that's still below thresholds for at least linear thermal damage to samples at those wavelengths. So all of these techniques that I showed today, in vivo imaging in realistic situations has been demonstrated.
All right. I'm afraid we're going to have to move on. I'd like to thank our speaker again.